Okay, okay. Second problem. So this problem was actually very has a pretty straightforward solution. Okay, so let's read it. It says a school has a right triangle shaped garden with an hypotenuse of 10 meters. One of the students has the idea of divide the garden with a 6-meter straight fence, straight, it's missing a T, beginning in the right angle and perpendicular to the hypotenuse as shown in the figure below, in order to achieve different purposes of organization, which don't really matter for our purposes. Okay, so is this idea viable? Explain if the student's idea is possible or not. So our goal with this problem is to prove if this idea it's even achievable, it's even possible. Okay, so the problem provides us with this figure. The referred figure is this one. You have a right triangle. Check, this is the right angle, and the hypotenuse is this one, the opposite to the right triangle, and it measures 10. And the such referred straight fence is supposed to be this one from the right triangle to the hypotenuse, and is perpendicular. So perpendicular means it makes a right angle. Okay, so and it's supposed to measure the length of the fence is supposed to be 6 meters. Okay, so the problem is already providing us abstraction of the problem, so we can jump direct to the abstraction. Okay, and this is the abstraction: the triangle, the hypotenuse of 10, and this side of length 6, and we want to prove if it is possible, this construction is possible. Well, and remember that making a draw is not a proof. Never it is a proof. I can put whatever number I want here. I can put, for example, 60. If I put 60, it's pretty obvious it is this is impossible. Because if this is 10, this the measure of this side must be less than 10, and this as well must be less than 10. So in not in Euclidean geometry, in this geometry, this side, the length of this side cannot be 60. You can see clearly that, don't you? It's pretty obvious that if the idea was put a fence of 60 meters, pretty obvious it wouldn't be achievable, couldn't be done, because 60 is too way larger. Okay, but what about 6? 6 is a length, 6 is a number that seems to be possible, could be. It's not that obvious if it is possible or not, so we have to prove it. And okay, in this problem you can use all your geometry brain, all your geometry skills, and your geometry powers to turn this triangle just in your head. Take this triangle and turn it in order to make this triangle. Yes, now this is the right angle, this is the hypotenuse of 10, and this is the side of 6. Okay, so remember, a draw is not a proof. Is this possible or not? Well, since this is a right triangle, you should only remember from the previous stages that, for example, in a circle, if you make the central angle, for example, this angle, this is, let's say, this is 30 degrees. Yes, 30 degrees. So it doesn't matter how long the sides of the angle are extend. This is also 30 degrees. Yes, and this side, let me take another marker just to make sure you're following me. this side of the circle is also 30 degrees. Yes, I am not talking about the length of the circle, because if you are talking about the length, you have to use the equation S equal r theta. But we are talking about the degrees. Okay, so here is 30 degrees, here is 30 degrees, here is 30 degrees. But something happens if you take, instead of the central angle, the angle inside the circumference, but with the same endpoints, with the same endpoints that the central angle. If you do this, as you know from previous stages, this is the half. This angle, the measure of this angle is the half. So instead of 30 is 50 degrees. Yes? And that happens always. You take a central angle and extend it to the circumference. Okay? And instead of take the central angle, extending to the circumference, the same endpoints. Okay? So in this configuration, you have 90 degrees. 90 degrees. This is a right triangle, so it means it's 90 degrees. So we can write a circumference here. A circumference here is not that well drawn because I am not very good at drawing. Oh my god. Let me give my best try. Okay, this is a circumference. So since this is 90, remember this is the diameter. All this is the diameter. So all this is 180 because this is the half of the circumference. All this is the half of the circumference because this is the diameter. Okay, so this means since it's the half of the circle, all this, remember, all the circle, the full circle is 360 degrees. So it means that the half of the circle is just 180 degrees. Okay, 180 degrees. So if the full circle is 360 degrees, the half of the circle is 180 degrees, and we are taking the, like this situation, yes, the angle extend to the circumference. Okay, so that's the reason this is 90. Okay, because we are taking the half of the circumference. This means that you can move this point in wherever these points of the circumference. Okay, you can put it here, you can put it here, you can put it here, here, and all these triangles, all these different triangles, imagine that you are moving the triangle. All these triangles have the hypotenuse of 10 and the right triangle, the right angle. Okay, they all have the same condition satisfied. They all have the same condition. They all have the hypotenuse of 10 and they all have the angle of 90 degrees because it's the half of the 180. Okay, 180. So it's the half. Okay, so basically all the triangles that can have this configuration are here in this circumference. Okay, and the length of this side is what is changing. Okay, the 10, the hypotenuse of 10 and the right triangle is constant in every triangle, but this length is changing. It's not the same in all the triangles because you are like moving the triangle. So this triangle is this measure is changing in all the triangles, and we already know that the diameter is 10. This means that the radius is 5. Okay, so which one of all these triangles has the bigger has this side as the bigger? Okay, as the bigger one. Of course, is the one that is in the middle. Okay, the one that is in the middle, because all these are actually shorter. Okay, and this one that is in the middle is the one which has the bigger length of this construction. Okay, and what is this length? What is the bigger length possible? Well, if it's going from the center to the circumference, of course, is the radio of 5. So as you can see, the radius is 5. So the maximum length is actually not even 6. It's less than 6. So the maximum length that can be is not even doesn't even reach 6. The maximum length is just 5. So this construction is not even possible. It's impossible to have an hypotenuse of 10, a right triangle, and that this side has a length of 6. It's impossible. The only conditions you may have are the hypotenuse of 10, the right triangle, and maybe a side less than 5. Less than 5, because you have all these possible solutions. All these possible solutions. But all these possible solutions are less than 5, because 5 is the radius of this circumference and is the maximum length that this construction can have. So 6 is greater than 5, so 6 is not even possible. Okay, 6 is not even possible as a solution. This means that the idea of this student of put a 6-meter fence, a straight fence of 6 meters long, is not even possible. Okay, so pretty straightforward solution, a very geometric solution, and that's the kind of thinking I want you to have. The possibility and the skill to manage to order your brain geometrically and make this kind of configuration of these kinds of construction. Okay, to turn the triangle, construct your own figures on the figure you already have. Remember the geometry you already know. There is another solution to this problem, a more algebraic solution that I want you to let you know, but in the next video. Okay,